Hello everyone, welcome back to another video about AP CSA, and today we'll be covering Unit 8 of AP CSA, which is about 2D arrays. My name is Tianling Cheng, and you can also call me Rain. And in today's video, we're going to be covering what are 2D arrays, access and modifying 2D arrays, 2D array methods, and some practice problem associated with this unit. First and foremost, what is an 2D array? In programming, an array is a collection of elements of the same type. A 2D array, also known as a matrix, is an array for arrays, allowing data to be organized in rows and columns. And to help you visualize this, I have posted a diagram below, which is basically what an array consisting of 4 rows and 4 columns would look like if it was drawn out. And now, to declare an 2D array, I have given you an example which creates an array consisting of 3 rows and 4 columns. To start with, we will first declare the data type, and in this specific example, I am going to declare an array type int, which is a 2D array consisting of only int type variables. And then we declare the array name, which in this case is num. So the 2D array that I've created will be named num, and when I call functions or methods with it, I'll be using the name num. And for the 3 and the 4 inside the square brackets, I'm declaring the dimensions of the 2D array, in which case the first will always be representing the rows numbers, and the second one will always be representing the column numbers. So in this case, it's 3 rows and 4 columns. And to access 2D arrays, first, we're again going to declare the same array that have the dimensions 3 and 4. And by setting the element at row 1, column 1 to 10, I will be using the assignment operator equal and just simply set num, the row 1 and column 1 number of num, to 10. And to access this variable, all I am doing is again using the assignment operator equal and setting x, which is of int type, to equal this number. So as I print x out, the result should be 10. And now we'll be covering the important technique of traversing through 2D arrays. This is a technique that we'll be commonly using in problems dealing with array list, and 2D arrays. And to accomplish this technique, you'll need 2 for loops, one on the outer layer and the other one built inside the other for loop. And commonly, while we're using traversing through 2D arrays, the outer layer of the for loop will usually act as the function that traverses through each row of the matrix or 2D array, and the inner layer will traverse through all the columns. And this type of arrays, or way of traversing through the array, is called row measured traversing. If you want to perform column measured traversing, which is we just have to reverse the order, placing the column on the outside and row on the inside. And so in this example, we'll be using a row measured traversion. And the first thing that you have to do with the outer layer is create a new variable called row and set it equal to 0. And for the limit, we'll limit the variable row to matrix.length, where at the place of matrix, you replace it with the name of the 2D array that you want to traverse through, and then set the row number to +1 after each turn of after each time that the for loop has been ran. And on the inner layer, you will create a new variable col, set it to int type, and set it equal to 0. And for the limit, we'll set col to matrix row dot length, which means that the limit will, in most examples, since different rows of 2D arrays will contain the same amount of variables, normally you can replace the row with 0 and will not cause an error, since the function would check, the for loop would check matrix 0 dot length, which means that will check the first row of the 2D array and get its length, so the amount of element in the first row, and use that as the limit for all rows. However, just to be safe, I will normally put matrix row dot length, which means that every time it is ran, every time row changes, it will calculate a new length and use it for that specific row. And for the last part, you just have to embed your code inside the inner layer of the for loop to accomplish this. Now, others, though it's not my favorite thing to do, but others would also sometimes use enhanced for loop. It's fundamentally the same as a for loop, but sometimes just more abbreviated and shorter to write with. And a lot of MCQ questions also test you on these, so it's always good to know how to write these. And the first thing you do, as usual, is calculate the number of rows, but do be aware that while declaring the variable role, you should declare as int type arrays instead of simply int type, because each row will contain a individual array instead of containing individual int type elements. And for the inner layer, you just simply declare as int type, and in the end, you just have to embed your code inside the inner layer as usual. And another thing to note is that while you're calling, since the variable column is already been declared as int type, while you're calling, you do not have to call matrix row column. Instead, you just have to call the variable column col and it will appear. Since it appears as an int type, you can do calculations straight up with the variable column. And now I've chosen a practice question for you to practice and give an honest reflection of how well you've done in this unit. And I encourage all of you to pause the video here and try to attempt this question yourself. And now I believe that all of you have attempted the question yourself and will be tracing through this question together. So the first thing that I normally do when I receive an array list, or 2D array question is draw out the array table, which in this case will look something like this, where the blue numbers indicate the indexes and the red numbers are the actual elements. And looking at the method, the first thing that I realize is that this is a row major traversing program, which means that it will typically traverse through the elements in an array and row before increasing the row number by 1. And the actual checking method of this checks if the number is even or odd. And if the number is odd, it will plus 1 to the actual number, while if the number is even, it will times it by 2. And looking at the starting indexes, I realized that the int row actually starts at 1, while the int column also starts at 1, which means that in this case, only 2 numbers are traversed or checked by the program, which are elements with the index 1, 1 and 1, 2. Therefore, these 2 elements will be traversed. And when the first element is traversed, it will first check if this number divided by 2 will have a remainder of 1, in which case it's false. And then it will check if the number divided by 2 will have a remainder of 0, in which case it will be true. So the procedure will be ran and 2 will be times 2, which will end as 4. and 3, in which case we'll first check if the number divided by 1 will have a remainder of 1, in which case is true, so it will be given a +1 to its value, so it will become a 4 instead of 3. However, because this is not an else if nor an else, but instead both are if statements, so the second if statement will also be traversed, even if the first if statement is executed, and therefore 4 will be divided by 2 and the remainder will also equal to 0, in which case the value returned will be true, and 4 will then be timed 2, which will be equal to 8, and therefore the correct table will look like the given, so in which case the correct answer is actually C. This question might be a bit tricky if you didn't realize that both if statements will be ran, so we have to pay careful attention while looking at practice problems. And this is my credit, and do visit these websites. They're very helpful during my learning experience with Java, and thank you guys for watching.